Hello everybody. In this video we are going to study about truth table, excitation table, characteristics table and equation of flip-flops. Okay, so the different types of flip-flop which I have considered over here is SR flip-flop, D flip-flop, JK flip-flop and T flip-flop, right? So you see, starting with SR flip-flop, I have taken the truth table which you are already familiar with. Okay, so you can see my other earlier videos where I have described the flip-flop. So here I will go just shortly and rather briefly, and I will explain you about the topics, that is excitation table, characteristics table and equations, right? So starting with SR flip-flop, the truth table is SRQ I have taken. So 0 0 0 1 1 0 and 1 1 I have taken. Okay, so for 0 0 you can see it is last value, for 0 1 is reset, for 1 0 it is sets and 1 1 invalid. Okay, now keeping this in mind, if I design the excitation table, what I am doing is that I am taking the present state and the next state. So present state is defined by Qn and next state is defined by Qn plus 1, and I am taking S and R. So now you see, if the condition is 0 0, okay, so what will be the input of S and R, that I have to find out. Okay, when it is 0 1, what is the input, what is, if it is 1 and 0, what is the input, and when it is 1 1, what is the input. So that I have to find it out over here. Okay, so let's have a check. So the present state is 0, in the future also I want 0. So what are the best possibilities? Okay, so best possibilities is, I'm writing over here, let's say best possibilities is 0 0. Present is 0, future should be 0, that means last value should come. So S and R should be 0 0. You can see that two table over here should be 0 0. The next condition is that it should be 0 1. Why? Because when R is 1 and S is 0, it should be reset. So if it is 1, it will come to 0, if it is 0, it will come to 0. Okay, reset condition. That means you can see this R part is don't care, maybe 1, maybe 0, nothing, we don't bother for that, but S should be compulsorily 0. Then we will be getting next state as 0. Okay, from the present state 0 to next state 0. That's why we have written S equal to 0, R equals to don't care. I hope it is clear to everyone. Now next condition, if I see, let me clear it out. Okay, so if I see the next condition, it is present state is 0, next state is 1. Okay, how to get it? There's only one possibility is that as per the truth table, S should be 1 and R should be 0. When S it is 1, R is 0 set condition. Okay, so I'm getting S1 R 0. Okay, now coming to the next one, it is 1, it is going to 0, present is 1, future will be 0. What is the best possibilities? Reset condition. So S is 0, R is 1, reset condition. Last state is 1, present state is 1, last next state should be 1. What is the possibility? Possibility is what? 0 0. So present state will be in the next state, that is last value will prevail. Okay, if it is 0 0. The second possibility is S is 1, R is 0. Okay, then also set condition will prevail, right? That means 1 will come. So that's why S is don't care and R is 0. So this condition I have taken it over here. Okay, I hope the excitation table for SRF is clear to everybody. See, basically set means 1. Okay, we consider in this way that set means 1 means the sense memory is 0, 1 is a data, and when we give 1 0 condition, memory becomes set means 1 will come. So that only we are thinking over here. It is in one state, it will come into one state when set condition will be given. Otherwise, again, if this is 1 coming as a 1, this is the last value is prevailing. So two possibilities, 0 0 or 1 0. So S becomes don't care and R becomes 0. Okay, so this is the excitation table of SR flip-flop. Now we'll come to the characteristics table. So here what I have done, I have taken the same present state as Qn, then S and R, and Qn plus 1 is the next state. Okay, so basically we see when 0 is given, the present state 0 is there, we are giving 0 0 input. Okay, what will be the next state, that we need to check it over here. Again, 0 is there, if you are giving 0 1, what is the next next value will come out. Okay, that means indirectly we are saying that Q1 present state will affect two values, either 0 or 1, not more than that. Okay, so when 0 value is there with the present state, we'll give all the possibilities of S and R and we'll check what is the next state. Okay, similarly we'll change the present state as 1 and give all the possibilities of S and R to see what is the next state. So you can see over here, see Q1 is all 0 and I given the SR value as 0 0 0 1 1 0 1 1. I have checked it out what is the next state. Then again I have repeated the same thing with the one value of present, that is Q1. Okay, so by keeping in mind excitation table and truth table, I got this one. Okay, I'm just explaining few part of it. That is, see, 0 is there, I'm giving 0 0, I'll get 0. Okay, 0 is there, I'm giving 0 1, I'll get 0. Why? Because reset condition. 0 is there, I'm giving 1 0, set condition, I'll get 1. Okay, in the future 0 is there, I'm giving 1 1, invalid, that is don't care, I got. Similarly 1 is there, I'm giving 0 0, 1 will come. 1 is there, I'm giving 0 1, 0 will come because reset condition. Okay, again reset condition, so 1 is there, I'll get 1. 1 is there, I'm giving 1 1, so invalid condition, so it is don't care, so I got this. Okay, now we need to find out the future equation, that is my characteristic equation. Okay, the equation is for qn plus 1. So to find the qn plus 1 equation, I need to design a kmf for qn plus 1. So for that who will be dependent, qn, s and r. Okay, so you can see I have taken a 3 variable kmf over here, qn, s and r, and I have implemented the values of qn plus 1 over here. Okay, in this kmap I am finding one quad and one pair. So from there I am getting the equation qn plus 1 equal to s plus qn r complement. This is the characteristic equation of SR flip flop. Okay, similarly for D flip flop, you can see over here I have taken the truth table, okay, which you are already familiar with. Excitation table I have taken, you can see present is 0, future will be 0 when D equal to 0. Present is 0, future is 1 when D equals to 1, because we know whatever value we give to D, that will reflect in the output. Okay, similarly over here present is 1, output future is 0 when D equal to 0, present is 1, future will be 1, obviously D equals to 1. So this is the excitation table of D flip flop. And now I'm going for the characteristics table of D flip flop, where I have taken present, D and the next state. So 0 is in present, what should I give to D to get 0 in the future? Obviously 0, I given 0, I got 0. 0 is there, if I am giving 1, I will get 1. 1 is there, if I give 0 from the D, I will get 0. 1 is there, if I give 1, I will get 1. So I got this table. So now for qn plus 1, I need a kmap and the values of D and qn. So that I have done it over here. I designed the kmap and implemented the values from the characteristics table, and then I am finding only one pair over here. So qn plus 1 equals to D, and we know very well that whatever you give to D, the value, the output will also come the same. Okay, so this equation states the same thing, future is equals to D. So whatever you give in D, in qn plus 1 you get the same thing. So this justifies. Okay, next coming to JK flip flop over here, the truth table is over here. As I've told you, I'll repeat once again over in the truth table of JK flip flop. You can see the last state, that is 1 1 is last value complement. So this last value complement is not this last value, the upper one. Okay, before giving 1 1, whatever input you have given, I got a value, that value's complement will come. For example, if you have given 0 1 before giving 1 1, so it's reset condition, so over here reset condition complement will come. Okay, but if at all you have given 0 0, okay, or let's say you have given 1 0, okay, and the value is 1 because it's condition, so when you give 1 1, 1's complement, that is 0, will come over here. This last value's complement means whatever you have given before this input, okay, that is the last value. Okay, not this one, right? Now we have designed the excitation table for JK flip flop over here. You can see present is 0, future I want 0. How? Obviously it will be 0 0 or it will be 0 1. So this is don't care, this is 0, just like SR flip flop. Okay, and accordingly present is 0, next is 1. Okay, when is possible? When it is 1 0 or it is 1 1, because 1 1 means it's toggled. Okay, that's why it is don't care over here is 1. 1 0 1 is there, I want 0. Okay, what is the possibility? 0 1. Okay, that means reset will be there. Okay, otherwise it will be 1 1, then it will toggle. Okay, so this is don't care, this is 1 1 is there, I want 1. Okay, possibility is what? 0 0 last value, or it will be 1 0. Okay, why 1 0? Set condition. Okay, so this is don't care, this is 0. Now we'll go for the characteristics table of JK flip flop. I have taken the present state, that is q1, j and k I have taken, and qn plus 1 I have taken. So 0 is there, 0 0 value, just like I have explained you for SR flip flop, same thing. For all zeros all 4 combination, then for 1 all 4 combination, and accordingly we'll check the values in the future. So you see 0 is there, I give 0 0, it is the last value, 0 will come. 0 is there, I give 0 1, 0 will come because of reset condition. 0 is there, I am giving 1 0, so set condition. Okay, 1 0 is there, I am giving 1 1, it will toggle, so I am getting 1 over here. 0 is there, I got 1 over here. Okay, now 1 is there, I am giving 0 0, 1 will come. 1 is there, 0 1, 0 will come. 1 is there, I am giving 1 0, 1 will come. Okay, why 1 is come? Because set condition, and here 1 means it will come 0 because toggle condition 1 1. So now I have designed the kmf for qn plus 1, taking the values of q1, j and k, and implementing the values from the table to this map. I am finding what? I am finding one pair over here horizontally and one pair over here. Accordingly, I am getting the equation qn plus 1 equals to j, qn complement plus k complement q1. This is the characteristics equation of JK flip flop. Okay, now come to the last one, T flip flop. So the truth table is over here. When t equal to 0, it is 0. When t equals to 1, it's toggle. Toggle means whatever value is there, it will come the complement of that one, right? So depending on that, I have designed the acceleration table over here. You can see present state and next state, and t is over here. So 0 is there, I want 0, so obviously t will be 0. 0 is there, I want 1, it should be 1, then it will toggle. 1 is there, I want 0, toggling is required, so I will give 1 over here. 1 is there, I want 1, toggling is not required, I will give 0 over here. So this is the excitation table of t flip flop. Come to the characteristics table of t flip flop. Qn present state, that is, then t, then qn plus 1 in the future. Okay, so I have 0 in the present state, I want 0. Okay, or let's say I'm giving 0, I'll get 0 in the future. Okay, because there is no toggle. 0 is there, I'm giving 1. Okay, from t, so it will toggle, it's toggling to 1. 1 is there, I'm giving 0 from t, so it will not toggle, I'll get 1, the same value. 1 is there, I'm giving 1 again, so it will toggle, so it is coming at 0 in the future state. So depending on this, for qn plus 1, I designed a k map over here, two variable qn and t I have taken for the map, and the value of q and t I implemented over here in the k map. I am finding two singles, this one and this one. Accordingly, I am getting the equation qn plus 1 equals to t qn complement plus t complement qn. Okay, this is the characteristic equation for t flip flop. So this is how we are designing the flip flops, or we are not designing. By this way, we are understanding or implementing the excitation table, characteristics table, and equation of different types of flip flop. Okay, thank you for watching my video.